Today we'll be learning the basics of the quicksort algorithm and how it works. Quicksort is considered to be one of the fastest and most efficient sorting algorithms. This is an overview of how the quicksort algorithm works. Initially, the number 5 is chosen as a pivot as it is in the middle of the dataset. The numbers in the dataset are organized on the left or right of the pivot depending on whether they're smaller or larger respectively. The pivot is initially moved to the end of the array and is placed between the two partitions after everything is sorted. A quicksort is performed on each partition again and again recursively until the array is sorted. Here is a live visualization of the quicksort algorithm in ascending order taking place. Let's start by picking a pivot. We'll pick 2 as the pivot as it's in the middle of the array. To make comparisons easier, we'll move our pivot to the end of the array. We will now scan the array from left to right with the goal of moving all values smaller than our pivot to the left of it and all numbers larger to the right of it. We can see that 5, 8, 9, and 7 are all larger than 2, so they can stay in place. However, 1 is less than 2, so it should be moved to index 0. None of the numbers are larger than 2, so we can move 2 to its correct placement in index 0. The left side of our array has been sorted. The numbers on the right side are now 9, 7, 5, 6, and 8. Let's choose 5 to be our pivot. We'll also move it to the end of the array. 9, 7, 8, and 6 are all larger values than 5, so we can move 5 in front of other numbers in index 2. Let's pick 8 as our new pivot and move it to the end. 7 and 6 are smaller than the pivot, while 9 is larger, so we'll move 6 to the left and 9 to the right. Now that our partition is sorted, we can move the pivot to its correct place. Our final partition contains the numbers 7 and 6, so we choose 7 as the final pivot and move 6 to the left, as it is smaller than 7. And we're done! Here's an example of a quicksort algorithm in Java. The main method is called quicksort, and partition is the helper method. The quicksort method uses recursion, meaning that it keeps calling itself to break the array into smaller partitions. Recursion allows the algorithm to keep dividing the array until each part is simple enough to be sorted directly. The method's goal is to place the pivot in its correct sorted position, and then partition the array into 2 halves. One with numbers smaller than the pivot and one with numbers larger. Each half is then quick-sorted again, following the same process. The method also has an if statement that checks whether the start index is less than the end index. This allows the method to stop once there is nothing left to sort. The partition method does most of the work as it rearranges the elements around the pivot. The pivot is first moved to the end of the array to make sorting easier. Values that are less than or equal to the pivot are moved to the left side of the array by swapping it with the element at the boundary. Once all elements have been compared, the pivot is swapped back into its correct place right after the last smallest element. This guarantees that all values on the left are smaller than the pivot and all values on the right are larger. Quicksort then repeats this process on both sides of the pivot until the entire array is sorted. Let's run this sorting algorithm on our dataset from earlier. As you can see, the data is sorted in ascending order. Thanks for watching.